Hello, everybody. Okay, we're still building the body of the robot. Okay, so let's go back to where we left off last time. Let's see. Okay, okay, we're back into OpenSCAD, and this is our blank screen again. Let's bring up what we had last time. So I gotta adjust something here. Something's goofy. Okay, so file, recent files, robot version 1. Okay, this is just a simulation of what the servo motor looks like and what you guys have done. Nothing too exciting at this point. We don't have actually the body, and you can't really print the servo motor because it's got the electronics inside aren't going to be there. But it's a place to start. And I'm gonna do a save as. Just because of what I want to do is I want to keep the revision level on this, so we keep all the old copies. Okay, so this is robot v1.scad. We're just going to change that to 2. And sometimes I forget to do that. It's not a huge deal. The way I do my files, I get copies of everything anyway. But it's probably a good idea. So let's start with the, okay, we need to mount these things onto a frame. We need the frame. And the question is how thick and how heavy do we need the frame? How strong is this plastic? If you haven't played with a 3D printer before, it's we're printing what we call PLA, which is a really inexpensive material. It's actually made out of corn. It's PLA is polylactic acid. It does eventually biodegrade. It's slow. You can supposedly you can compost it in a commercial composter, which means if it's above 140 degrees and in a wet environment, eventually it supposedly degrades. I have not tested that, and I know that if you leave it in water, it gets brittle after a while. So I mean, it's not really good for outside use, but we're trying to get it through the semester, and that's about as far as we're really interested in. Okay. So let me flip over to the document camera for a second here. Here's some things I've printed out of PLA. So this is just I printed some simple shapes at one point just to see how strong things were when somebody asked, well, how thick do I need to make it? So this is 5 millimeters by 5 millimeters, and it's really amazingly strong. So I mean, if our units aren't all that big, you can get a lot of strength out of something just this size. So if I'm building a frame, 5 millimeters is probably adequate. If we make it bigger, where we suffer is it takes more material, and also the print times go way up. Now I've been playing with some other projects, and this is, let me get back farther even. This is a cube, and it's it has some interesting problems to print, but it's amazingly strong. I bet I could just about stand on this thing. And this is 10 millimeters on the side, so this is way heavier than you need. But I was doing it for another project, so it was so it was okay. But this thing, we'll talk about why later. But it takes like 11 or 12 hours to print, so. You can imagine if everybody in the class is doing that we're going to run out of time. Okay, so let me set that aside. But some primitive shapes would be really convenient. And I'm going to just keep adding code to this thing, like on the servos. If we don't want them, we can just temporarily. Well, let's make that bigger so you can see it. Okay. In fact, I'm going to close the window down just a little bit. I'm going to put just a couple of slashes in front of it just so I remember that it's there. And I'm just going to start adding more code. What I want, let's do a primitive shape. Let's do a ring. Now, we've talked about the differences and stuff like that before. So, but I want to make a ring. And I want to do one other thing that we haven't done in here before. And I'm going to do a module. And I'm going to call it ring. And I want to be able to specify the size as what we call an argument to this. So I'm, and I don't know what size it's going to be, but I'm just going to call it SZ for size, okay. So when this gets called, I want it to actually be that. Let's, and then before it's going to print, I need to actually call it. So I'm going to say ring, and I want it to be, this is going to be the diameter. Everything else is going to be fixed. I want the diameter to be, let's make it Just for out of curiosity, let's make it 60 millimeters in diameter. Okay, so I'll just say ring at 60. So what happens when I do that is when I say ring 60, it's going to call this module and it's going to do everything in the module. But everywhere it has SZ, it's going to put in a 60. So let's just start off by let's make the cylinder. Okay, so cylinder D equals, well, I can say D equals SZ. So the diameter is going to be the 60. Okay, and I'm going to say the height, well, we just said 5 millimeters is actually pretty strong. So we'll just say H equals 5. And I'm just going to do that. So now on my machine and on most of the machines, if you just hit the F5, it redraws everything. And here's our 50 millimeter diameter or 60 millimeter diameter cylinder. And but we want that difference. We want it to be a ring. And I want the outside, I want that thickness to be, the thickness is 5 millimeters, but I also want the width of that ring to be 5 millimeters. So I could subtract something. So let's do a difference function here. Slide that in. And I want to subtract off, but I want it 5 millimeters less on both sides. So I can say the diameter, which is going to be SZ, but I want to minus 5 on each side, that'd be 10. Okay, minus 10. H equals 5. And, you know, if I don't put in that swirly bracket at the bottom for the difference to make it match, then it's going to be unhappy with me. Okay. Now you see a really funky artifact that's left over in the display. That, and what causes that is we're subtracting a surface from a surface, and it's got a 0 thickness surface there. So it's really not sure what to do with that. And we've got actually 2 of those. We've got one on the top and one on the bottom. We can fix that. So what we can do is we can increase the thickness of the one we're subtracting off. We can make it much bigger because I mean it's subtracting, so it doesn't show up anyway. So I'll just make it 10. And so when I say redraw now, that top surface is now gone, the funky thing, but I still got one at the bottom. And I want that one to go away too. So what I can do is, you know, I made this thing 10 millimeters tall when I only needed 5. But I can slide it down 1 so that you don't have that 0 width thing. And I want to translate it 0, 0, any amount. Just minus 1 is fine. Okay, so now that I've done that, now the ring looks good. Okay, so it's 60 millimeters in diameter. Well, now when I need a second ring, you know, I can do that. We'll have to move it a little bit. I can say translate. And I can move it in, we'll just pick X direction here. Let's move it over 20 millimeters. And I want to make it a ring. And I'll make it 60. And hit redraw. Okay, so, you know, again, with just very primitive shapes, we're only using cylinders in this particular one, we can actually get pretty good things. Now, you know, these flats on the sides, I'm just going to leave them. I mean, I can do the $FN equals whatever and make it smoother. Remember, everything in the computer is going to be flat surfaces, and it's just making them really small makes it look round. That's the way we handle that. But, you know, I can just leave them the way they are, and this will probably be fine. So let me add one more just to make this look interesting. In fact, it's going to look exactly like this one. I'm going to copy, paste it, but I'm going to translate it in another direction here. Okay, so, you know, we can do whatever we want with this. So we've got this ring function that we can have. We can make it smaller, we can make it bigger. I could have made this one 100. I mean, you know, we can't really go below, you know, something really small. If I make this one 30, you can see that it starts getting small. I don't know what's to do when you get too small. There's 20. There's 10. The center goes away. What happens when you go smaller than 10? I mean, it's not going to like blow up or something. It just does it. It just gets rid of the zero diameter smaller one subtracting off. Just goes away. So you can play with that type of stuff. Okay, so there's a ring. So when we want a ring, we can do that. Now, if you want to get rid of part of the ring, let me go back down just to 1. Just again, double slashes just says ignore it. Maybe I want to put it back later. Okay, so we're back down to our single one. You know, so maybe I want to do something other fancy here. Maybe I want to just have a quarter of the ring. So I can come in here and I can say difference. And I want to start with that ring, and I want to take off a cube. Remember, if we don't specify where a cube goes, it puts it at the one corner of it right at 0, 0, 0. So that'll just take a quarter of it out of it for us. So we'll just do that. Cube, and we're going to make it bigger than 60. So let me just do 100s. I know it's bigger than we need, and then I need to close that bracket, otherwise it's going to get picky with us. Okay. And you can see that little artifact there of that 0 thickness wall again. And we can get rid of that. We just want to translate it down 1. Here's where I said translate down 1. I can just copy that. I'm lazy sometimes. Okay. Paste that in there. And that takes care of that. So, I mean, I can really do some really easy shapes here. Okay, so ring works good. I want to build, a frame. It's going to be square. I mean, it's going to be, okay, I've got this thing, you know, I mean, it's just the, you know, something like that, just the square thing that I can start bolting stuff to. So let me call frame, module. Got to tell it's module first. And I'm just going to call it frame. And I'm not even going to say how big it is because we'll actually adjust it in here. So I need a frame. Okay, well, I don't want the ring right now. I want to get rid of all of this. So let me just comment it out. I mean, I could delete it, but then, you know, then I wanted to know what I did later. Okay. Okay, so let me down here, let me just call it. Nothing in there yet, so nothing's going to happen. Okay, so we've got a frame. So now what I want to do is I want to put in, make a decision of how big this thing's going to be. Now, we've got limitations on how big the printer is. I mean, the printer can print a pretty good size piece. The printer is right over my shoulder here, this white machine. And we'll print with that a little later here, and I'll do a time lapse so you can actually see how fast it prints. But it's about 200 millimeters by 200 millimeters. Don't go anywhere near that big because it takes, you can have this thing print for days if you want. I mean, it just gets really busy. So what we want to do is we want to keep everything fairly small. Maybe, you know, there's no real reason to go above about 100 millimeters by 100, 120 millimeter size. You know, something on that frame, time frame or size should be fine. So let's just make it, let's make our frame 80 by 100. Okay. So, and we can do it as 5 by 5s. So if I do a cube, and I'm just going to do x5, let me just do 5s all the way around. 5, 5, 5. Okay, we're just doing a cube here. Let me hit F5. There's my, this is 5 by 5 by 5 millimeters. Now, I really want this to be 120 or 180 by 100 is what I said. So I'm going to go, let me just put a comment in here. 80 by 100. Okay, and it's 5 millimeters tall. Well, the 5 tall is the last one here. That's the 5. So let me change this to 100 in the Y. Okay. You can see the little marker there. It's gone out to 100. So there's the one piece. Now I need one going the other way. So we'll just we'll copy this. We'll paste it there. And I want it to go 80. So this one, let's go back to 5 and let's make, oops, this one the 80. Okay. Now I want the first one again, but I need it translated over. So I mean, I want to translate it. I don't want to translate it minus, but I mean, it's like, this is typing and I get lazy, as I said. Okay, there's translate. And I don't want to translate in the Z direction. I've got an X, Y, and a Z. So this one is another one of the hundreds. So that's this piece here. And I want to translate it this way. So this is X, that's Y. I know it's small print, I'm sorry. And this is X here. So I want to go in the X direction by something like 80 or something like that. So let me just translate in the X direction by 80 and see where we get. Okay. Well, what we have right now is, here's the 80, that's 85. I'm 85. So what I did is I put it a little bit too far. I really want to subtract the 5 back off of that so it only the edge comes back up to the edge. Some of this you have to just play with to figure out what's happening. So let me just back that up to 75. If I don't go far enough, if I only went 65, you could see where it's at there. And I want this edge here to slide over another 10. So, so I can, you can play the game, or you can think about how it goes. But okay, 70. Okay, then you could say 71. And you get up there 74. And you could see when things don't line up. But when I get to 75, it should be, and it does. It matches. Okay, so now there's 3 sides. I need my 4th one. Okay, so if I just copy this one and then change all the numbers again, copy, paste, and I know the translate's going to be moved. Let me change that to zeros for the moment. And this has got to be, well, it's not 100 this way. This one's got to be 5, and this has got to be the 80. So it's 85.5, just like this line, a couple lines up. And the translate, I want to go, okay, so I want this to be translated in the Y direction. And if I said 100, it's going to be too far, just like before. So I need 100 minus 5, so it's going to be 95. So let me go back 95 here. In the Y direction. Okay. So here's my basic frame. Next video, we're going to figure out how to mount the servo motors on this thing. That's the next thing to do. So we'll get to that. Okay, let me just clear up a couple of things here. Okay, so there's our frame. We call it, those things are just comments down there. And today is actually it is the 14th. So let me change the date on that to make sure. And this is version 2. I'm just trying to make all the comments in here match what's in the file. Let me save this. Save your work. Okay. And that's where we're going to stop for the moment. And the next video will be mounting up the servo.